Hi everyone, welcome to the webinar and thanks for joining us today to learn a little bit about HOMER Grid, our newest product from HOMER Energy. HOMER Grid was created to help you design behind-the-meter systems that can help reduce demand charges. And today we're going to spend a little bit of time talking about HOMER Grid can help you design the system with the best rate of return. We're going to do a quick demo so you can see how HOMER Grid works. And then we're going to open things up for questions. I do want to let everybody know that we're recording today's webinar and we'll send out a copy of the recording as soon as it's available, probably in a few days. So even though we're doing questions at the end, you can feel free to ask questions at any time by using the question and answer panel located in the GoToWebinar interface. We have Arby, one of our engineers, with us on the line tonight, and she's going to help answer questions. We can't promise that we'll get to every single question, but she'll answer as many questions as she can. Before we get started, I just wanted to take a second to introduce today's team. My name is Leanne Baronet, and I'm the Director of Marketing Communications here at HOMER Energy. And I'm joined by Steffi Klauder, our Product Manager. I know a lot of you are probably already familiar with HOMER Energy, but if not, I just wanted to take a little bit of time to let you know who we are and what we do. We grew out of the National Renewable Energy Lab. So HOMER was originally created as part of the Department of Energy's Village Power Program in 1992, and then it was privatized in 2009. So we are the exclusive developer and distributor of the HOMER software. And HOMER stands for Hybrid Optimization of Multiple Energy Resources. Over the past decade, it's become the global standard for designing systems of all shapes and sizes. Everything we do here at HOMER Energy is built on top of the HOMER engine, so it's the foundation for all of our products. And that includes our flagship product, HOMER Pro, and it also includes HOMER Grid. So what that means is that HOMER Grid shares a lot of the same familiar elements as HOMER Pro. So it shares key features like combining engineering and economics in one powerful model, helping you determine the least cost options for your system, and simulating real-world performance to give you optimized design. So we know that HOMER Pro and HOMER Grid share a lot of the same features, but how are they different? At the basic level, it boils down to this. HOMER Pro is for designing microgrids of all shapes and sizes, and HOMER Grid is focused on behind-the-meter systems, specifically for commercial and industrial customers who want to reduce demand charges. So with that, I'm going to hand things over to Steffi, and she's going to talk a little bit about demand charges and how to adjust them with HOMER Grid.
Thanks, Leanne. So as Leanne mentioned, HOMER Grid is specifically designed for lowering electricity costs through demand charge reduction and energy arbitrage. So let's talk about the first value stream, that demand charge reduction. If you think of your utility bill to be made up of your energy charges and your demand charges, those energy charges are like the mileage odometer. How far did you go? The demand charges are comparable to what your speedometer is displaying at a given time. How fast are you going right now? So both the odometer, the energy charges, and the speedometer, the demand charges, make up your utility bill. And depending on your utility tariff, the weight of each of these two charges will vary. And in fact, let's see. For more and more customers, the demand charges are making up more of their bill. So depending on what tariff you're on, the demand charges can range between 30 to 70% of your bill. And these demand charges are often based on the highest 15-minute period, which can affect your bill for the whole year. So the trend generally is that utilities are shifting their cost structures and generally increasing their demand charges. It's probably counterintuitive to most end electricity customers. So using the car analogy, it would be like being charged not just for the mileage, but in addition being charged for the highest speed at which you travel over the previous month. So that one time that you needed to speed up really quickly and pass a semi, that's caused your whole monthly bill to be much higher and more costly. So HOMER Grid is designed to solve that problem. How many batteries do you need to have on hand to avoid these high demand charges, for example? And the graph that is shown here, that AC primary load, that's how much electricity you need. So the red is before, and then the green is after you install the hybrid technologies. So in this case, the solar installation plus batteries is reliably reducing the peak and staying below that black line, that imaginary limit, demand limit is what we call it in HOMER Grid, and thereby reducing your demand charges. So just quickly, how do you reduce your demand charges? I might have hinted to this, but you install hybrid systems. So with solar alone, you can reduce your demand charges by around 7%, according to research from NREL and Lawrence Berkeley National Labs. But if you add storage to that mix, you can reliably reduce your demand charges by 42%. So given that you need a mix of technologies to reliably reduce your utility bill, HOMER Grid will help you design this hybrid system, and that design process can be pretty complex. So HOMER Grid will help you quickly evaluate any potential projects that you're considering, and it's meant to really facilitate this process and allow you to quickly model your utility bill and the hybrid system. And so each project is unique. The customer type and the load shape is critical to consider in this feasibility analysis. And you're constantly considering the trade-offs and ultimately trying to answer questions like, how do you get the most out of your investment? So we're bringing in HOMER Grid now, and HOMER Grid is for modeling the hybrid behind-the-meter systems where a reliable electricity network is connected. And the software can quickly and accurately suggest the best size and technologies to reduce your utility bill through demand charge reduction, which we talked about, through energy arbitrage, or through PV arbitrage or self-consumption. And so using the philosophy that guides all of HOMER Energy's products, HOMER Grid determines the best mix of technologies and the size and achieves the lowest cost solution. The technologies that HOMER Grid evaluates include solar PV, multiple chemistries for storage solutions, generators, and even combined heat and power technologies. So HOMER Grid can help you understand the value and impact these technologies have in reducing your utility bill. And we try and make this process as easy and as quick as possible. We've integrated with a third-party database and tariff provider. So if you are in US, Canada, Mexico, Australia, you can quickly select your tariff by name and continue modeling. And this saves time and allows you to not have to spend hours building up your tariff within our certain software structure. If you want to compare the utilities to one another, you can compare multiple tariffs. And likewise, you can compare specific components to each other and decide exactly which technology would have the lowest cost over the project lifetime. So the library in HOMER Grid has thousands of components that can facilitate this exercise in evaluating the trade-offs. So you can compare whether a lead acid battery would be cheaper than a lithium-ion battery. And how does all of this analysis happen? Well, first, you have to start with your inputs, including where you're planning on building this project and what technologies you may be considering. Then you'll need to specify which tariff your facility is currently on and whether a different tariff might be possible, a reclassification as that's sometimes referred to. If your project can utilize any incentives which would help the economics, you'll need to add that information. And of course, your facility's electrical needs or the load profile should be uploaded if at all possible. If you don't have your facility's load profile, we try to give you some starting point and examples. In the US, we've connected to the OpenAI database of load profiles, which you can use it as a starting point. But of course, the more accurate your inputs, the better your results will be. And HOMER Grid runs, depending on your inputs, hundreds to thousands of simulations and then ranks these simulations based on the lowest net present cost and presents you ultimately with the economics and the engineering for your hybrid system. It sizes the system architecture, calculates performance details, and provides you with the financial information. So I touched on many of the values that HOMER Grid has to offer, starting with demand charge reduction, the value stacking aspect of PV arbitrage and energy arbitrage. We pride ourselves in the robust storage model that HOMER Grid uses, which greatly outdoes the competition, and the powerful optimizer, which helps you find the right size for your hybrid technologies. And as far as the cutting edge dispatch strategy goes, our development team has come up with a perfect foresight methodology to make dispatch decisions, and I'll go through that in more detail during our demo. As I mentioned, we're trying to facilitate this exercise and make it quick and easy for you. And to help you, we offer the global resource data and integrate with the tariff database. And ultimately, the value of HOMER Grid is to get detailed and accurate and completely customizable results where you can explore and quantify various risks that are associated with building your project. And now I will jump into a HOMER Grid demo. Let's see. So I'm going to talk about an example of an office building in downtown Sydney, which has both an electric load and a thermal load. So opening up HOMER Grid, this is the setup page. You'll want to choose your project location, either through the map or through typing it into this bar here. So you can do Sydney, Australia. And the point of defining your location is to allow you to easily download your resource data. So we'll go here and download the solar data that we have. The NASA database is one of two databases which we offer. The NREL database is the other one, depending on your location. So now we have the resources. So after you've defined your location and these high-level economic parameters, you should define your electric load profile. So we'll go here. And there's a couple different options. If you have your interval data, you can import it. And if that interval data is, say, incomplete, or if the meter fails somewhere along the way, you can import and edit it. For the US, we have these OpenAI database profiles. That's very handy. It's 16 different building types for locations across the US. And this third option is the option we'll use today. We'll use the standard commercial load for our office building, and we'll have a peak in the months of January. Pressing OK. So now you can see this heat map, which popped up here and expresses at which hour of the day and during which day of the year is the demand for electricity the greatest. So generally there's an evening peak and generally daytime on, nighttime a little bit less, pretty constant throughout the year. And you could change this and customize this. If you wanted to redo your load profile, you could go to show all months and edit that, or add more variability to your load profile. And so those are quick and easy things you can do if you don't have your interval data. But again, the most accurate thing you can do when considering demand charge reduction is to know your peaks. So you might have noticed that as I added this electric load, it popped up into this upper right-hand corner, our schematic. And if I ever want to get back to this page and redefine something, edit the variability, for example, I can always click back there. So now that we've defined how much electricity we want, we'll define the utility right now, the tariff that we're on currently. And based on that location that we entered, it's populated this postal code here. And then you can click Get Tariffs, which will access the third-party database that I mentioned for tariffs. And by name, you can go through and choose which tariff your facility is on. So we'll do, let's see, small business, time of use. Okay. And whenever you choose a tariff, I encourage you to do this visualize utility bill button here, which allows you to gain insight into what information is coming through from that third-party database. So here we can see that this time of use demand structure has an off-peak time, which has approximately 17 cents per kilowatt hour, and has an on-peak time of up to 36 cents per kilowatt hour. And similarly, you can hover over the demand heat map here. It's a little bit misleading because all of the demands are between $11 and $12. So these demand rates here are a combination of your electric load, which you defined, and this tariff. So that's the variation here is based on you have a bit higher of a peak in certain times of the month or certain times of the year. And an important step here, this is where you kind of fact check your baseline case. And I would encourage you to compare this utility bill representation with your facility's actual utility bills, because probably any hybrid system which you'll need to, which you're trying to pitch or, prove value for, it's going to compete with this utility only system, and the economics of that are listed here. So this should be as close to reality as possible. Another thing, a last comment on the utility page, the third-party database which we've connected to is excellent for the US. We've had some user feedback that it's not as good for the Australian rates. So if you find that you can't find your tariff in this list, or if you look at the details page here, if you click this link, it'll go to the page where the information is coming from. So this looks pretty good. This was updated in 2017. But if there's ever a time when you need to create your own tariff, you can use this simple tariff builder and define energy charges and demand charges. And we are currently implementing a more complex version of this. So please email us if you are unable to create your rate exactly just with this simple tariff builder. And we can provide you with, can be one of our first users and testers of our more complex model for this. So given that, let's say this is accurate, this accurately represents our office building, we're going to consider what other technologies might be interesting in this system. And we'll do PV. There's two ways to choose your PV system. You can choose from this drop-down menu here, or you can choose from this complete catalog menu, which has thousands of different PV modules. Today we're going to do just the generic flat plate PV. And you'll notice that I'm faced with a lot of numbers here. And if you don't know what they are, that's okay. So HOMER Grid and HOMER Pro, for that matter, are both economic models. And therefore, they can consider, if you want to, economies of scale. So it allows you to say that smaller size installations, say residential PV, has a price of approximately $3 a watt, and utility scale PV drops down to below $2 a watt. And so it allows you to make the trade-offs more easily. If you just have a price for your PV system, which you know, of course you can just have one line here and that'll be the price all the way across here without considering economies of scale. That's perfectly fine. In our case here, these numbers by default are in American dollars, so they'll be a little bit off for Australia. And we can, if you ever get stuck, you can go down to these required changes here, and it will help you find your way essentially. So here I clicked on currency tariff currency mismatch, and I'll redefine the Australian dollars here. And that goes away. So now that we've defined PV, we can see this here. Our prices might be a little bit higher than they would be, but that's okay. It's AC connected, so it's connected to the AC bus. And what other technologies you might consider? We'll consider storage. And again, we have the options for this drop-down menu here, which has generics and partners. And it has the ability for the complete catalog, which has many, many more components. And I'd just like to point out what we're so proud of here. So the battery models, there's several different battery models that HOMER Grid can use. There's this idealized model, there's the kinetic model, and then there's this advanced storage model, this ASM tag here. And the ASM is a very complex model because it takes into account thermal degradation and rate-paced capacity limitation. So it's among the more sophisticated models on the market. And so I think we should take advantage of that sophistication and use the ASM battery in our model default. Okay. And again, these numbers are to take into account economies of scale. Depending on which component you choose, there'll be different pricing information by default. And often if you're choosing a non-generic component, there won't be pricing listed because it is difficult to get manufacturers to give pricing. They'd like to be contacted about their components as opposed to sending out false pricing information. So often with the manufacturer components, you'll have to define the pricing for yourself, or the generic components can give you a good starting point. And now we'll follow these red required changes here. We need to add a converter. So we did that here. And for all the system, all the components so far, we have been using this HOMER optimizer as our sizing tool. And that we'll continue to do that. That allows it to find the right size for our system. If we wanted to say, no, I have a PV array, I know that my PV array is 200 kilowatts, then you can enter that there. Or if you wanted to use the optimizer, but say the maximum size of my roof is actually, I can only hold a megawatt, you can add that as an upper limit to the HOMER optimizer. There we go. Okay, so now that we have no more red required changes, we could just go to our results right now. But I wanted to just quickly show you how to use our thermal capacities here and CHP. So this is a perfectly fine system, but we're going to add a thermal load to it. And we have the same options. We can import it, we can use OpenEI, or we'll use this synthetic load profile for the commercial. And good, and that popped up right here. So the different components that can serve a thermal load include the spoiler. And of course you can change the pricing here, or a generator with CHP technologies. And we'll do size your own. And of course, you should always enter your specific pricing if you have it. That's obviously the most accurate, and that'll give you the best results. And the final thing I'd like to show you as far as the design side goes are these incentives, and that can really affect your economics, so it ends up being important. We have some incentives built into the software, like the US ITC, US makers, and we have several templates that you can use to create your own incentive. So if we were trying to model LREC, for example, I think we would use a production-based incentive, and that would apply 8 cents per kilowatt hour with, say, no maximum. And we could limit it to the first 10 years. So given you can use any of the other templates, there's also capacity-based template or capital-based template. You should be able to represent your state and local incentives that way. And let us know if we need to build anything out as far as the incentives go. So again, we have no more red required changes, and we can go to our results. So now it's calculating, and each optimization actually takes a couple seconds to up to a minute. So the calculation in total can be approximately between 5 and 30 minutes. And the reason it's taking long, maybe relatively long, is because it's making decisions for each time step in the simulation. And if you're running your model with 15-minute time steps, the results will definitely be more accurate if you have a 15-minute demand charge. But the calculation will take longer. So similarly, if you're running with sensitivity analyses, which we didn't actually show in this example, but that also will compound your runtime. But it is because it's making decisions for every time step in a very robust and thorough way. And we are working on the performance of it, which should be ready by our next larger release in June. So since we don't want to wait that 5 to 30 minutes, I've already calculated this file. And once HOMER Grid finishes calculating, you'll see this results table. And it's a summary of different system configurations and combinations. And it's showing for each system configuration what's the right size for each of the components. And it's ranked from top to bottom by net present cost, showing the winning system having the lowest net present cost. So we can go on and consider all the high-level economics of this table, or we can dive deep into the details and choose a specific system to look into. So we'll consider our solar plus battery has the lowest net present cost, and we'll see what that has to show. This cost summary table will allow you to see and check that your incentives are being accurately represented, and your capital and O&M costs are being accurately represented in the model. We have a cash flow tab and the compare economics tab. And I think that one of the more powerful things here is a graphic that really explains what the payback time means. So your current system is your hybrid system, and your base case is that utility only system. And where those lines cross is the payback time. So for each of the components in our system, we can look at a tab and see when is the battery operating, when is the PV producing. And one thing that's really helpful is to see a breakdown of this value stacking that we were talking about. Here is the reduction in energy charges, and here is the reduction in demand charges. So $22,000 are being reduced from the demand charges, and seems like a lot of savings are coming from having that PV. If you wanted to see a time series plot, which would show how much is the PV producing, it's a generally oversized, maybe an oversized system. And after we've installed our hybrid system, what are the grid purchases? So I'll do a before and after like we had before. Red is before, green is after, and the green always has to stay below this imaginary demand limit. And so the power of HOMER grid is that it finds this demand limit for each month or for each time of use rate, if necessary, and tries to find the right balance between installing extra batteries and paying that demand charge. So this is your view into what the dispatch is doing. So you can make sure that it's operating as you'd expect it to, that the battery is engaging during on-peak times, all of that you can see through this time series. And I think the last things I'd like to show you are our reporting capabilities. We can, if you are certain that this is the system you would like to create a report about, you can use this simulation report here. And it will give you essentially all the information in these tabs here, and it will allow you to bring over specific views from the time series plot into your report. So you can create a report about this certain system. If you would rather have a report about, say, the top 5 systems here, you can use this optimization report button, and that will give you, let's see, more. There it is. It'll give you information over those top 5 winning system architecture types, including information on the site, when does the peak load happen, and what are the savings on the utility bill. All right, so given, I think that concludes the demo. I'll turn it back over to Leanne, and she can explain how to get started.
Okay, thanks, Steffi. If you haven't already, you should go to our website and get started with a free 21-day trial of HOMER Grid. You can do that by going to homerenergy.com/trygrid and clicking on the Try Now button. You get to try it for free for 21 days, and that's with the full functionality, and there's no credit card required to get started with your trial. If you've already given it a try and you're ready to buy, we've got license options available right now. HOMER Grid is currently available in both monthly and annual licenses, and right now, to celebrate the launch of our new product, both of those licenses are discounted at 50% off through August of 2018. So a monthly license is now only $250 a month, and an annual license is only $1,500 for the year. And one other great thing about our launch specials is right now, if you purchase a license through August of 2018, our combined heat and power module is included for free with all licenses. Okay, so I'm going to hand it back over to Steffi to take some questions. We've had a lot of really great questions come in, and take it away, Steffi.
All right, thanks. The first question we have, which is a very good question, is HOMER Grid a different product than HOMER Pro? And the answer is yes. They're different for many reasons. They solve different problems, and they have different dispatch strategies to do that. So the point of HOMER Grid is to design a hybrid system which will reduce your utility bill, and that can be through the demand charges, through energy arbitrage, or through self-consumption. And the point is that it's connected to a reliable grid. This contrasts with HOMER Pro, which though HOMER Pro does have some grid capabilities, it's not a tool that will quite effectively reduce your demand charges. HOMER Pro does microgrids, and so it does standalone systems. and it has a wider range of technologies that can be a part of microgrids. HOMER grid, so they differ in their dispatch strategy, and also the tariff database that I mentioned, that is only in HOMER grid. Likewise, our incentives feature is currently only in HOMER grid. So they're two different tools, and they're meant to solve two different problems for distinct markets, and that's why they are two different products at this point. One question is, how do I transfer my Pro license to the HOMER grid license? And we are offering kind of a dollar-to-dollar discount. So if you are on a HOMER Pro license, but you realize that grid is actually the product for you, we will give you credit for the remaining credit on your HOMER Pro license can be applied to your HOMER grid license, no problem. And as far as what functionality is coming to HOMER grid soon, I mentioned that we're working on that more complex tariff builder. And that will be a part of our June release. Additionally, we're planning to integrate the Helioscope API and PV-Syst production data. That will be, you can bring that into HOMER grid. We have a question about how are battery performance metrics captured and optimized? So if I could go back to the tab, let's go back to the software. You can see here, so it's sized 136 or 135 kilowatt hours of batteries. Here's the information about the battery, which is happening. So quantity, the storage wear cost per kilowatt hour, the lifetime throughput, and then the metrics on how much energy does it supply, how much energy out. Those metrics you can see, or in the time series plot, you can see when it's discharging. We have this state of charge line here. That way you can make sure that the dispatch is making the correct decisions that you'd like to see. So you can see when it's discharging, when it's recharging, generally charging during the day, discharging in the evening. That's probably what you'd expect. Let's see. So is demand charge reduction based on perfect monthly forecast? So I mentioned that the dispatch strategy is using what we call perfect foresight, and that means it has it looks ahead 48 hours, and it knows the next 48 hours of the solar resource that will be available, the load that will be required, the electric load, and the price of electricity, the tariff structure. So it looks ahead at those three things and makes decisions accordingly. And we've talked to some controller companies, and this seems, though optimistic, in the realm of reality, given the different machine learning that's been going on with electric loads prediction, and given the forecasting capabilities for solar. So this is a best case scenario, an optimistic case scenario, but not unreasonably so, in my opinion. Can grid model solar and storage connected directly to the grid, not necessarily for behind the meter? Right now, HOMER grid is focused on the behind the meter value streams, like demand charge reduction, energy arbitrage, self-consumption, and like the self-consumption is best modeled if you have an electric load. There you can model essentially in from the meter systems with HOMER grid, but it's much more suited at this time for behind the meter value streams. But of course, the vision for Homer Grid is to be a very, the grid connected product. So ultimately, we will, based on customer feedback, we'll be thinking about how we can add in some ancillary services or capacity market value streams into the product, though probably not before, not before the June release. We have our June release planned. Could you manually enter different tariff components for future years? So what you can do in Homer Pro, in Homer Grid, is model 2 different tariffs, but you cannot say that this year we'll have this tariff, this year have that tariff. We don't have a multi-year functionality in Homer Grid yet. And then we have a couple questions on, does Grid handle variable time of use rates? And yes, it does. That is built into the tariff database. And another question related to variable rates. Some portions of the bill are variable. Can you add and amend this info? The ability to edit a rate, which is coming through that third party, that's the capability that we're building in right now. So that's not available yet. Right now, you can just choose from the tariffs, make sure that's right. We're designing this more complex tariff builder, which if you need that to model, let us know. We can provide that little tool for you. And that will have the ability to edit and amend the info coming through from that third party. Wind is currently not modeled in Homer Grid, but starting in June, it will be. I think that got most of the questions that we have. So thank you very much for your time. I'll throw the mic back over to Leanne, who can conclude our webinar. Thank you so much for your time.
Okay, everybody, just one last announcement before we go. Our conference, our 6th annual Homer International Microgrid Conference, is happening again this year. It's going to be in San Diego in October 8th through 10th. We have a really fantastic venue this year. We're already starting to get some really great speakers lined up, so we hope you'll join us. Early bird pricing is happening right now through May 15th, and also the call for speakers is open through May 6th, so go to microgridconference.com to check it out. That's it. Thank you guys so much for joining us today. We really appreciate it. Bye.